Hey there, today I'm going to walk you through using TAMV, which is Tool Alignment Machine Vision, or Automated Nozzle Alignment using computer vision software. It can run with Duet 2 and 3 hardware running RepRap Firmware 2 or RepRap Firmware 3. So first things first, you got to start out with a fully homed up machine. And then what you do is you jog your nozzle and your end stop over to wherever your microscope is placed on your bed. Now in my case, I'm using it at 150 in Z, and I just open up TAMV GUI on my Raspberry Pi VNC session. It's now a graphical user interface program, so it's quite easy to use. I connect up to my printer, and you see there I'm connected, and I define my controlled point. Now this is where TAMV is going to align all the nozzle offsets to. So you better make sure this is in smack dab middle of your end stop, or as close as you can get it to whatever you're using for your Z probe. Now here I've just set it up and I just click OK to save the location that I have chosen. It might take a few tries to get it just right, especially when you're zoomed in so close and tight. So do it to whatever you're comfortable with, and then all you have to do is just click Start Tool Alignment. Now TAMV will go and fetch the first tool automatically, pick it up, jog it over the microscope, and do what's needed first, which is camera calibration. This is where the software needs to understand how the space of the camera coordinates maps to the physical space of the printer itself. So it does a series of about 10 movements in 0.5 millimeter radii around the center point. When it's done, it'll also tell you what the current millimeters per pixel value is. You'll see in this case it's 0.01 millimeters. And then it'll proceed to align the nozzle itself. So there it's done with the first tool. It's going to pick up the second tool and it'll bring it over to the nozzle, and you'll see how the algorithm's working in real time. Now you can enable something called X-ray, which will help you troubleshoot if your nozzle isn't very clean. What is the computer vision looking at to detect your nozzle? So it's just looking for circles at this point. There we go. Tool number 2 is done, and it's going to pick up tool number 3. You can also enable something called loose detection, which basically is a more relaxed way of finding the circles. But this can cause a few problems where it creates false positives, like you can see here. So try and see what works best for you. In future releases, we'll be allowing you to tweak these parameters in real time as well. And there we go. We've aligned all 3 of our nozzles. Now it prompts me if I want to apply these offsets to the machine, which will just run the G10 commands for the tool offsets straight into my Duet controller. I can just click cancel right now, and then I can go over to the debug information window and I scroll all the way down to the bottom, and you'll find your G10 commands conveniently placed there for you to copy and paste into your config.g file. That will just permanently store those offsets on the controller, so in case you restart your machine, you haven't lost your nice alignment results. And that's it. As you can see, we aligned 3 tools in about 2 minutes. It's very fast, it's very efficient, it's open source. Check it out, and you can reach us on the Jubilee Discord if you need any help. I'll leave the link down in the description for you to find us. Thanks a lot.